Hey guys, happy Monday. It's April 13th. We're back at it after spring break. Hope you guys are doing okay. So if you remember back to before spring break, we were doing special right triangles. So we're going to continue with right triangles this next week, but today, as kind of like an intro back into things and not jumping right into the new stuff, I wanted to review radicals because what we're going to do over the next couple of days requires radicals, and I figure this is a good time to kind of review those rules. Okay, so I do not know how Miss Brown taught you guys last year. I probably should have asked her, but I don't know. You can learn radicals multiple ways, so you can break it down with prime factors or you can break it down with the perfect squares. In my honest opinion, I think the fastest way is to break them down with perfect squares. Okay, so that's how I'm going to show you guys today. And I think it's the fastest way. Now, I will say this. If some of you have Casio calculators, this does it for you. So that's why, you remember I've called it like the cheating calculator before. So, sure, I mean, I'm not going to stop you from using the Casio calculator, but you really technically should be able to do these with no calculator or like just a basic calculator on your phone. Okay? I'm going to do it with no calculator, and hopefully we don't make any careless mistakes. All right, so the first thing I'm going to do is I'm going to write out the perfect squares. So a perfect square, to remind yourself, is like a number times itself. So 1 squared is 1 times 1. It's going to be 1. Okay? 2 squared is 2 times 2, which is 4. 3 squared is 9. The reason I'm writing these down is we're going to use these for all the future problems, okay? That was 3. So 4 squared is 16. 5 squared is 25. What number am I on? 6 squared is 36. 7 squared is 49. 8 squared, 9 squared, 10 squared, 11 squared. Now, I'm going to go dot, dot, dot. I'm probably not going to give you too much higher than that, but it is good to know our perfect squares. Okay, so what I'm going to do is I'm going to ask you to try to figure out what perfect square goes into 24, and then we're going to break it down. So I would say, well, obviously, you're only going to start here, right? Because you know that 25 doesn't go into 24, so you have to basically start at the number that's the greatest one before that number. So 16 is the greatest perfect square before 24, okay? So I'm starting at 16. Does 16 go into 24? So I'm going like this way. All right. 16 does not go into 24. Does 9 go into 24? No. Does 4 go into 24? Yes. Okay. So that's the number that I'm going to start with. Okay. So I'm going to do 4 times 6. And now when we look at it this way, the square root of 4 times the square root of 6 gives me the square root of 24. Now, this number right here is a perfect square, okay? So what is the square root of 4? Well, the square root of 4 is 2. Notice the radical goes away because it's a perfect square. And so whenever you have a perfect square, the radical disappears. And so 2 times 2 gives me 4. That's why it's a perfect square, okay? So then the square root of 6 is not a perfect square, so it has to stay. So our final answer here is 2 root 6. 6 is one of those numbers that you think it should break down because of 3 times 2, but are either of those perfect squares? And the answer is no, so that's as far as you can go. Okay? All right, let's try another one. All right, so we're going to try to find a perfect square that goes into 90. So we know we're not going to go to 100, so we're going to go here and to the left. 81 does not, 64, and we're going to keep going down the list. Well, it's all the way to 9. So the square root of 9 times the square root of 10. So the square root of 9 is a perfect square, so it comes out of the house, is what I call it, or the radical, because it's a perfect square, and then 10 is not, so it stays in, and you're done. Okay. All right, now what about 49? Well, if you see 49 is in this list, so it itself is a perfect square. So your answer is 7 and you're done. Okay? So 7 times itself gives you 49. So that one has no radical whatsoever. All right, let's try to break down 50. So 50, we're going to look at 49 and below. So 49, no. 36, no. 25, yes. So we're going to have the square root of 25 and the square root of 2. Well, the square root of 25 is 5. So our final answer is 5 radical 2. Okay, this should be review. If it's not review, I'll link some more YouTube videos so you can watch. Okay, so number 5 has this 3 out front, and then it's like stuck beside this radical. You can imagine that there's an imaginary, that's the same word. You can imagine a multiplication sign there. Okay, so we're going to break down 32, but we don't need to forget to bring this 3 over for our final answer. Okay, so let's just do this part first. We're just going to do the 32. Okay. All right, so 32, we're going to go here and below. So 25, 16 is a yes. So 16 and 2. Okay. Let me show you really quickly. Some of you may have said, oh, well, I know 4 goes into 32, 4 times 8. So if you used 4 and 8, that's good. Oops. But that's not all the way simplified because then 8 can break down. So when you have a problem where 2 of the perfect squares, so in this case 4 and 16 went into 32, you always want to take the greatest. Okay? So we want to take the largest perfect square. So we're going to take 16 and 2. So square root of 16 is 4, and the square root of 2 is not a perfect square. So I'm going to have 4 root 2. However, I need to remember that this 3 was out front, so I need to bring the 3 here, okay? But then that looks like 34, and that's not what I want to do. So what you need to remember is you need to remember that you're multiplying, okay? So our final answer here is we can only multiply the whole numbers times the whole numbers, no radicals. So we're just going to do 3 times 4, which is 12 root 2. Okay? So if you need some more practice on those, I'll link a YouTube video. There are many of them out there where you could kind of follow along to get a little extra practice. Okay. Now we're going to talk about division. We've done this already with the special right triangles, but I wanted to kind of refresh your memory. Okay, so is it okay to have a radical in the numerator? And the answer is yes. This is fine being here. Okay. This is fine being here. This is not, and this is not. So we'll go back and fix those in just a minute. For 8 and 9, but 6 and 7 are completely fine. Okay. Now the only thing we want to ask ourselves is, can they simplify? So can we break down 5? And the answer is no, because there is nothing that goes into 5 besides 5 in itself. Okay. So we're going to leave it like this. And then I'm going to ask you, does that mean we can simplify and divide both of these by 5? The answer is no, because one is a radical and one is a whole number. So they're very strict on their rules. You can only do it if they're radical, radical, or whole number, whole number. This is your final answer. That's really all you can do. All right, now with number 7, the 20 can break down, okay? So what perfect square, we can go back to our list up here. So we're only going 16, 9, 4, or 1. And you guys, we don't really even look at 1 because 1 goes into everything, and it doesn't really help us, quote unquote, break down the number. So we're just going to look at 16, 9, and 4. And 4 goes into 20, 4 times 5. So that's going to be 2 root 5 over 4, and then we're going to try to simplify from there. Okay, so we've broken down the numerator. We brought our 4 over. Make sure you just, keep it in the same quote-unquote level. So the numerator stays in the numerator, denominator stays in the denominator. And now you want to simplify this fraction right here. So 2/4 reduces by, we can divide both of them by 2. So we can put 1 root 5 over 2. Do we really need the 1 out front? And the answer is no. So I'm going to do like this, and then we're done. Okay, so that's as simplified as we can get. All right, now with 8 and 9, if you remember from special right triangles, we cannot ever leave a radical in the denominator, okay? So you may want to make that note to yourself. Do not leave radical in denominator. Okay? All right, so the first thing I want to ask myself is, can we break down the 6? And the answer is no, because if you go back to our list up here, you could only try 4, and 4 does not go into 6. So it's done simplifying wise, so I'm just going to multiply by root 6. Okay? Y'all remember that, where to get rid of it, you multiply it by itself? So here it'll be 4 root 6 over square root of 36. But I hope y'all will start just going straight to that shortcut that we talked about, because square root of 36 is a perfect square of 6. Any root times itself will give you the number without the root. Okay? And then we just need to ask ourselves, kind of cover up with your thumb, if you will, the radical, and look at the fraction and see if this can reduce. And the answer is yes, both of these are divisible by 2. So 2 root 6 over 3 should be our final answer. Okay? All right, with number 9, we have 8. So I'm going to go back to my list, which means I'm really only checking the number 4. Does 4 go into 8? And the answer is yes, it does. So that can simplify. So the square root of 4 times the square root of 2. And the square root of 4 is a perfect square. So we have 2 over, and then I'm doing this, breaking this down. So the square root of 4 is 2, and then we have to bring the radical 2 over. Look at all those 2's. Okay, so what I call the problem child, the quote-unquote problem child, is only the radical. Okay, the plain 2 can stay in the denominator. So I'm going to multiply by radical 2 on the numerator and denominator, and I'm going to have 2 root 2 over. Now, be careful. I got to bring this 2 first, and then when I multiply these 2, it's going to be root 4. Or, if you remember from our shortcut, we learned that it's just 2. So we're going to now have 2 radical 2 over 2 times 2. Okay, I'm running out of room, but I think I can make it work. All right, so that's going to be 2 radical 2 over 4. Okay? Everybody following? And so now I'm going to see if I can simplify this, and I can. 2 goes into both of them. I'm sorry, I'm going to have to write my answer over here. So my final answer will be root 2 over 2. Okay? So there are other ways to do this. If you wanted on number 9 to go ahead and get rid of the 8 to start with and just times by radical 8 on numerator and denominator, you certainly can. But I just think this is the simplest, most straightforward way. Okay? So I want you guys to try these 8 on your own, and see if you can give them a try. I'm going to put up a form for you to respond so I can kind of get some feedback before I go over them. And tomorrow we will start our actual right triangle trig. All right, great.